Okay, welcome to exercise 8 on page 90 of the workbook. And this exercise is asking us to find the exact value of the following limit as x approaches infinity of x times e to the 3 over x minus 1. Okay, so as we've been doing with our previous examples, let's start by just examining the form of this limit. Notice that there are two pieces to it. Okay, there's the x out in front and there's the part in parentheses. Okay, and we'll ask ourselves, how are each of those pieces behaving? Okay, well, the x part at the beginning, that's going off to infinity because that's what x is doing. Okay, so this has the form infinity times, and then the question is, what's happening to the part in parentheses here? Okay, so to answer that question, let's start maybe with the exponent here. So 3 over x. What's going to happen to that fraction 3 over x as x goes off to infinity? Well, if you think about it, that fraction is going to have to go off to 0, okay, because the denominator is getting big. And so what we've really got in parentheses is we're approaching e to the 0 minus 1. That's really 1 minus 1, which is 0. Okay, so this limit has the form infinity times 0, and you can look back on page 87 and notice that this was one of the indeterminate forms. That was a comment that was below the definition of L'Hopital's rule. Okay, so my question to you is, given what we observed here, what do you think the value of this limit is going to turn out to be? Okay, you might be saying we should get 0 because if we take 0 times infinity, it kind of seems like we should get 0. Normally when you take 0 times a number, you get 0 back. Well, surprisingly, what we're going to discover in this example is that we don't get 0. And that's the reason why we use this word indeterminate. We can't really predict what's going to happen without that limit, for that limit, without investigating further. Okay, so let's see what happens when we actually do this limit. All right, so I'm going to start by just rewriting this. Okay, and then we come to a little bit of a roadblock here. Okay, so the way that L'Hopital's rule works is we need our function to have the form of a ratio. In other words, a fraction, something divided by something else in order to use L'Hopital's rule. And in this case, we don't have a fraction, we have a product. Okay, something times something else. Okay, so to use L'Hopital's rule, there's an extra step in this problem. We need to rewrite our function as a ratio. How do we do that? Well, we kind of have to get a little sneaky with algebra. Okay, so one way to do it is to notice that we're starting with an x to the first power. We can move that into the denominator if we change the sign on the exponent. In other words, the function that we started with could be rewritten like this. E to the 3 over x minus 1 over x to the negative 1. That seems like a really strange thing to do, but it's just a way of taking the function that we started with and turning it into a fraction, okay, so that we can use L'Hopital's rule. All right, and so now we can go ahead and use L'Hopital's rule in the way that we've been doing it by just taking the derivative of the numerator and the denominator separately. To help us with this calculation, you might remember that 3 over x can be rewritten as 3x to the negative 1. Okay, that's going to maybe help in taking the derivative. And so, actually, I'm going to give myself a little bit more space here. Okay, so now we need to take the derivative of the top, and the derivative of e to the 3x minus 1 is going to be itself times the derivative of the 3x to the negative 1. That's the chain rule, and that's going to put a negative 3x to the negative 2 on there. Okay, and the derivative of the minus 1 at the end is just going to go to 0. Okay, and down in the bottom, what is the derivative of x to the negative 1? Well, that's just a power rule. We're going to get negative x to the negative 2. Okay, and so we've got an expression that looks a little bit ugly here. is there anything we can do to simplify that? Okay, well, notice that we've got an x to the minus 2 in the top and the bottom. We can cancel those. And we've got a minus sign in the top and the bottom, so we can cancel those and turn them into plus signs. So if we rewrite that, what's left over is just a 3 and an e to the 3x to the negative 1. Okay, and now that we're done taking derivatives, I'm going to rewrite that negative exponent as a positive again. Okay, 3e to the 3x to the negative 1 is really 3 over x. So what it comes down to is, can we take this limit that we have here? All right, well, let's see. So as x approaches infinity, what is happening to the fraction 3 over x? Well, we explored this a minute ago and convinced ourselves that that 3 over x is approaching 0. So this should be 3e to the 0 in the limit. And that gives us our answer, which turns out to be 3 in this case. Okay. So again, just to reemphasize, this is kind of a surprising result. We started with a limit that has the form infinity times 0, and we actually got an answer of 3. Again, illustrating why we use the word indeterminate. Okay? We couldn't have really predicted this answer of 3 without going through this process that we did. Okay, and as you do future exercises, you will notice this